Hello. Can you hear me? Can you see the screen?
Yes, I can hear and see everything.
Perfect. Okay. The two of you are in the first course or in the second course?
I'll be in the second course.
Okay. And okay. Oh.
Hi, Matthias. Could you please repeat the days for the first and second course?
Ah, yeah. If you participate in the first course or in the second course, was just a question. So I have a bit of overview. In which course? But give me a second. I should have somewhere the documents for that. Hi, Luca. Hi, Gaston.
Hi.
So, exactly. So Antonio should be in the first course, and Götztem. Okay, Wilfried is not here, and Lina, but she will probably appear. Okay. Yeah. So I will send out the information for the location. So this will be always like from 10 to 5. Yeah, we probably will stop like at 4:30 or so. Depends. I have to leave around 4:45. And this will all be in this house 20 building. I will send the information. You need a laptop for the course. So if you don't have a laptop or computer, please let me know. Basically like right now or like tomorrow, and then I probably can organize 1 or 2 additional laptops. Yeah, but otherwise you probably don't have to install anything, or I will send some information that you probably can try to install Anaconda beforehand. But if not, that we can also do this at the beginning of the course. Okay. Yeah. So what we will do today, that we go over this data curation and how to curate data, and that to the people who are here, I will assign some paper, and to the other people, they basically also get assigned some publications. And so that you have to work through the publication and try to get out the data from the studies. And this is basically this list of studies I presented last time. I now went over them again and did a bit of classification. So mainly, okay, which for the first course we mainly need the pharmacokinetic information to fit the pharmacokinetic models. For the second one, the pharmacodynamic is more important. So this is more like, okay, the 1 and the 2 here in this column, and then we have some priority, and they're this high priority are basically the important studies to do. And so the people who are in the first course, basically, they should get one of the high priority publications at the beginning, and yeah, hopefully have a short look before the course starts on Monday. Only these papers are not too big though, so that's like 3 or 4 pages to read. So this should be doable. Otherwise, okay, you have to work through it in the beginning of the course. Okay. Yeah, I will show it one example. Okay, what you have to do with such a publication, and then that you get a feeling, okay, what the workload is and how the data should look in the end. Okay, for that, first starting with a bit of presentation, and then going directly in the data curation. So for that, I assigned myself like one of the studies, this Quinn 2007. It's basically a super easy study, but it demonstrates the main principles. Okay, what steps do you have to do doing data curation? And yeah, some of the studies are like, okay, they're similar than the Quinn 2007, but they are, of course, like for every study, there are like some specifics. Okay, we have to figure out to together. Okay, let's start with that. Okay, so the main idea is to get out of the publications 2 kinds of data. The one is like I would say the most important kind of data. It's the time course data. for instance, that you have time dependency of the lisinopril. Yeah, but it could also be time dependencies of the pharmacodynamic readouts, like, I don't know, renin, aldosterone, blood pressure, whatever is relevant for the model. But the data is basically time course data, meaning you have like a time dimension, you have like a data dimension here, and you have sometimes error bars or error information, and sometimes you even have the individual data. In the end, this is basically information over time. The second kind of information we often have is pharmacokinetic parameters, or let's say pharmacodynamic parameters. And this is just stuff which was calculated based on this time courses, on this single values, and often with error bars and ranges for certain groups. And this is a second kind of data. So I would say the one is time courses, and this one we call more like outputs. So there's no time there often is a time dimension. Okay, this was calculated on 24 hours or something like that, but there's not multiple time points there. And I would say this is the two kinds of data. What we need in addition is the information. Okay, what were the subjects in which the things were measured, and what did they take, and how did this work? Give me a second. I have to figure out the chat here. Yeah, got some. Yeah, with the course dates, no problem. If you have more time on the second course, it's no problem. Yeah, no problem. Just participate in the second course. Yeah. So what do we do with this data? We prepare it. Let's say this is like this part which is called here like extraction. We extract from the publication the data from the figures, or like from the raw text or tables. And then we include it in this PKDB curation pipelines, where we extract the information from the figures, data sets, and additional metadata. And often this is like what I mentioned, like this subjects, interventions, and dosing information. We then upload this to the database, and there are like a lot of validation steps in between. And then if the data is uploading, it's in a very good format to automatically bring it together with the computational models. And so like this one step is, okay, we have to extract some of this data, bring it in this format, upload it to the database so that we can use it then for computational modeling. And the main thing which we use the data for is model fitting. We try to change our model so that the predicted curves in better agreement to this experimental data than with the model version before. And that's the main thing which we need the data for. We have to somehow compare model predictions with actual data, and this has to be in a format where we can do this automatically. Yeah. So how does this normally look like? So you have like some text information. There's often information about the subjects in here. In this case, this is a study for caffeine in different subgroups, males, females, oral contraceptives, no oral contraceptives. And then you see, okay, for the different subgroups, there was different pharmacokinetic parameters reported, like half-lives, volumes of distributions, clearances, and so on. And also the time courses here, in this case on the log axis. And so in the equation, as we try to figure out, okay, this were 13 normal subjects, males, this is the age range and so on. So this is information about the groups. So in which group was what measured. The second thing is, okay, what was given? And in this case, it was actually a 250 milligram capsule of caffeine with 150 milliliters of water. This is the dose. And in the end, what was measured is on the one hand, the time courses, and on the other hand, this outputs, in this case, pharmacokinetic parameters. So this is basically how this works. And if you do this for multiple studies, you can bring the data together and with things like meta-analysis and so on. So this is here, it's not so important, but it just shows, okay, if we have like this all standardized, we can compare between different groups. And for instance, in our case, it would be, we're mainly interested in lisinopril in pharmacokinetics, pharmacodynamics in healthy subjects, and renal impairment, and cardiac insufficiency. So we have these different subgroups, and then we would be interested, let's compare them the changes in pharmacokinetics and pharmacodynamics between these different subgroups. Here in this example for caffeine, it's smokers and or contraceptive users. For us, it would be people with different renal insufficiency or different problems with the heart. But in the end, it's very similar. We have to have data for the different subgroups and have model simulations for the different subgroups. Okay, that's basically it. Yeah, I put here on the link like the important information. You should have most of these. I'm not sure if this with this Zotero document works. You should be able to just click on the on this link and then get access to this Zotero library. Hopefully you should only see this XResearch, and there in this lisinopril there are all the PDFs in here. This online thing is not working so well, but in the end, okay, if you know what you're looking for, you can easily like access the PDFs, or you can just basically scroll through and see, okay, what the PDFs are. Problem is this is a bit mixed with this ramipril publications, but you should be able to get all the PDFs. I would say the important subset of documents you have to access is really like this PDFs of the study, especially the study you assigned to, and these are already in the repository. So if you go to this XResearch repository, there's this data subfolder, and before there were only the ramipril, data ramipril. There's now also data lisinopril, and these are the subfolders for the different studies, and there should all be the PDFs in there. So like to access the PDF for your study, okay, just go to the right subfolder and then click on that and see the information. So yeah, so we want to get the data out. In my case, okay, I assigned myself like a simple study like this KIN 2007, and so the first step one is doing, especially opening the PDF and having a look at the PDF. Okay, and then in your case, okay, normally what I'm doing is, okay, just have a quick skim over the paper. This makes often sense, like before you start reading in detail, just read the title and okay, so this is some quantification method for lisinopril in human plasma and liquid chromatography tandem mass spectrometry. This is I would say the standard method to quantify metabolites from pharmacokinetic studies. This is pretty standard, but here this is I would say the focus is not on, okay, we want to know something about lisinopril in certain studies, but this is they wanted to check if their quantification assay is working. And so a lot of what we read here will be about, okay, liquid chromatography, tandem mass spectrometry, and then it's also like a biomedical chromatographies journal. Okay, you can expect there's a lot of chromatography stuff like that, mass spec stuff we don't care about. Okay, and then normally you skim a bit the abstract. In this case, okay, there's basically you just see a lot of okay, here like lisinopril in human plasma. This is already like good information. So normally I just take a highlight tool and highlight the, oh man, if you can highlight, sometimes you're like, this is basically an ugly paper. You can see basically it doesn't have like the nice text, so you can't really highlight very nice, but normally I would just highlight certain things in here. So for me, it's like the important thing is, okay, we have human samples in plasma. Okay, and then skimming over it, and then you can see, okay, this is basically the spectra from a mass spec. We don't care about that. Lots of analytical things. More spectra. You also don't care. Extraction efficiency, stability. This is all mass spec stuff. And then we see tables, and here we see calibration curves. Calibration curves we're also not interested in. This is basically that they measure, they basically do assays, and they put in different concentrations, and then they see, okay, how much concentration do they measure? I think it's just interesting for you to get a feeling, okay, how good can people measure? And then this is like, if you see, like if you just if you prepare basically as good as you can, like a reference concentration, and then you measure it, and like for instance, then you already you still get like 5 to 10% error just in measuring here. So you get you measure pretty accurate, but you have two plus minus 0.2 here, like for the quantification. So it's like I said, you're pretty accurate, but you're like off around 5 to 10%. And this is just the analytics. Like it means like, okay, like you can just expect by measuring pharmacokinetics that you have a variation of 5 to 10% in your reported data points by just the assay to do it. And in this, I would say these are pretty good numbers, but this is like every data point which you read in a paper, it normally has like this, let's say, technical variability. And this can be pretty high. Like 10% is pretty good. Like if you go to omics data and so on, you often have like 15-20% of technical variability. And this, of course, depends a lot on the concentration ranges. Like for the if you go to the very low concentration and so on, your errors get bigger. Like if you go higher, your errors get less. You also see this here. Okay, if you do give very high concentrations, you have 3% error. If you have very low concentration, you have around 10% error. Okay. But that is all not so important for us. I think this is just like for, it's a general, very interesting information if you look at experimental data, or if you work with lab data, or if you do experiments and so on. This is pretty typical. And this you have to like always say, like if you do like some t-tests and if you do some analysis on basically you effects, biological effects which are smaller than this stuff, it's basically impossible to detect, or you need very, very large sample sizes. Okay, long story short. Okay, and they did a lot of this. Okay, we do calibration curves, and then we test our assay and see how good can we measure what we put in. But we're not interested in that because these are basically not actual samples. What we are interested in is basically like only this last curve here, where they say, okay, here now in the end, we did something. We did measure the mean drug plasma concentration time curve of lisinopril from the 4th subject after an oral administration. So here's is really like I said, this is a paper. There's not much pharmacokinetics in here. There's basically this one curve, and also not much information about this curve. The thing that we know is, okay, this was from 4 subjects after oral administration and so on. And so what we're looking for is if we can find like some additional information now, okay, what was the actual dose, what was given, and what were these patients or the subjects, these 4 subjects. And so normally you find this in a study section or so, like I just saw it somewhere. Sorry for scrolling so much. Experimental chemicals, man, sorry, introduction. So it's a lot of searching around, LCMS, sample preparation, selection of conditions. Sorry, I had the feeling I just saw that. Precision accuracy, application. Here, application. Here, application is probably here. The validated method was successfully used to quantify lisinopril concentration in a preliminary pharmacokinetic study. And the clinical protocol, which was approved, and so on and so on. Here, 4 Chinese. Oh, okay, we can't calibrate that, but okay, the important sentence is here. Okay, four Chinese healthy male volunteers participated in the study. So we know they were Chinese, they were healthy, they were male. They fasted overnight, and they got a lisinopril tablet of 10 milligrams. And then blood samples were taken, different time points here. The time points are often stated in the methods. So at 1, 2, 3, 4, and so on, until 36 hours, they took the samples. And then they did basically their assay, and they quantified it, and they showed all the data in figure 4. So here, this is basically, it's really minimalistic. Normally, you have much more information about the patients and the study design is more complicated, and they say a lot more about parameters which calculated. But here, you, in the end, we just know, okay, there were 4 male healthy subjects. They got 10 milligrams of lisinopril in a tablet, and this is how the curve is looking for them. But this is already really important information because like our model, if we give to the model like basically 10 milligrams, we want to simulate it, we should get curves which look similar like that. Okay, so what would we do? Like there's multiple steps. So the first step is that you take a screenshot of the things which you want to digitize. So we want to get the data out of this here, of this figure. So we should take a screenshot of this figure. and just put it into the folder where the PDF is. So all the data to one study should actually be located in the study. Let's create this screenshot, like try it as much the highest quality possible, and then you basically just save this under the study folder. So in this case, this is in this XResearch data studies, the Xenobril, and we did the kin 2007, and this is like basically the screenshot for the figure 4 PNG. Okay, so this would be the first thing, that we have like some documentation. Okay, this is the data we want to get out, because you often have to look at this at this data again and see it. Yeah. The things which I'm doing right now, there's in this XResearch there should be a document which provides like some curation guidelines. This is basically here in this data curation information. You can see this here, and there's like some markdown file which provides an overview, okay, of the things you should do during the data curation. There's a lot of information in here. I think the important thing is, okay, you have to install some libraries that you are able to upload this to the database, and then you have to do a certain thing about the data curation. Basically, the file names have it in a certain way, and the structure has to be in a certain way. So what I'm doing right now with this, okay, I created a screenshot. This is documented here in the document. So like the figures should be named like, okay, like this, and the tables like this, and then we need an Excel file like that, and so on and so on. So this is in this curation document, you find most of this information, and the things I'm showing right now. Yeah, in the end, perhaps I will just show a study how this should look in the end, that you have like a feeling for the data. So we can, of course, you can have a look at this data in the RamiPril subfolder. In the end, you will have like some structure which looks like that. So you have your PDFs, you have your screenshots in here. So in this case, it's, you see also it's screenshots for RamiPril and ramiprilat, which is a metabolite, and then some pharmacokinetic parameters here. Exactly, and some, okay, these are the figures. And then where you curate the data is like in an actual Excel spreadsheet. And in this Excel spreadsheet, there have to be different tabs. One tab where the group information is stored, one tab where the intervention information is stored, so what was given. And then you have like separate tabs for the figures, tables, and so on, where you get data out. So this is normally how this looks like. And then you have like some additional studies, like the study JSON and reference JSON, which yeah, provide some basically some additional information. Okay, a lot of things like okay, it gets more clear if you start working on that. And for me now, it's just that you saw basically all the documents, and then the important thing is for your study, read the PDF and get a try to do the screenshots and try to see, okay, what data could be relevant and how would you extract that. But the data curation we will do in the course. I think the important thing is like really reading the paper. Okay. Yeah, I will just actually I will just copy the I'll copy the 2 files for now, and from here, and just put them now in the skin in this skin 2007, and what's going on, and use them as a template. So the important thing is that all the documents are always named to your study. So here we need actually this has to be named in 2007. And here we would put in all the information. So we would in this information, we would definitely need like tab for the groups, tab for the interventions, and we would have one table for the figures. So we can already I would delete these sheets. We don't need them. And we want to create the figure 4. So I would just name this figure 4. And I would remove the data from here. And this is a pretty good template of, okay, what you have to fill out for the study. So I will put the screenshot in here, and so in the end, we know, okay, we have to get in here is the data from this figure. So this should be somehow here. In addition, okay, we have this interventions, and in the interventions, we encode basically what was done. So in our case, we only had one intervention. The study is always the study ID. So basically in the end, you just have to remember, okay, my study is like this. Here it's KIN 2007. So we fill out the study ID. And then you want to encode, okay, what was done in the study. And okay, there was not much reported, but we knew like there was a tablet of 10 milligrams lisinopril given. We would just write down, okay, this was a single, and it was single oral dose. And this was given basically at the time point 0. So, and then afterwards, okay, time point 0, they took all the tablet, and then they measured for 36 hours what was going on. And then we give this whole thing like just a nice name. And this is just an ID that we can access this intervention. So we encoded just, okay, basically here this oral single dose of a tablet of lisinopril of 10 milligrams. We gave it the name LIS10. And then we can say, okay, here in our figure, we measured this data, and the intervention which was done was the basically LIS10 was done. And in the group, we would write down, okay, what was the group on which this was done. So for the group, yeah, we have to try to write down as much as information as possible. But the group information is already like it gets much more heterogeneous and more complicated. In our case, okay, we just try to write down what we know. So in our case, okay, we know our ID is like the KIN 2007. We know we had 4 subjects, so this is basically our group size. And then we know not much more. We know basically like for this the species we know, these were all Homo sapiens. We know they were all healthy. And we know they were all 4 of them were male, as far as I remember. And we, I think we know that they were Chinese. So we can write down their ethnicity. Yeah. These fields which you use here in this database, they are defined in the database. And so you can look up, okay, what fields and what names you can use. Like for instance, here, if you read something and want to encode it, like for instance, here we want to encode that they are Chinese, as far as I remember. Then we can look it up here in the database. So this is the database for our project, the XResearch2023.com. And we have here like this small curation tab where we can look up things. So here we could just type in Chinese and see if we have some information for that. And this looks pretty good. And what we have here is, okay, this is basically Chinese, it's a choice. And here always basically the bold thing is what you write in the tables. But here, if you look things up, the important things here, like the front thing, the labels, and then, okay, what is written here? So it's Chinese, and we have to know, okay, how the field is called, and okay, I know this, it's called ethnicity. And so we can encode this information that they were Chinese by saying, okay, this group had an ethnicity of Chinese. Okay, and that's what we're doing now in this table. We saw the ethnicity of all 4 of them was Chinese. Okay, I think there was a bit more information in there. I probably forgot it already. So just checking 4 subjects, all administration. This looks good. And then I will just reread this information here. So they were all Chinese, healthy male volunteers. Okay. 10 milligrams blood samples, but we don't even know what was the body weight of these people. Yeah, we know still like there was some overnight fasting, but otherwise we don't know much about this. So this is really rudimentary. We don't even know a body weight or anything of these people. So let's look up the fasting. The overnight fasting we can also encode for this study. So there's basically here this field overnight fast, which can have like either be yes or no. And we can write this down for the study that we write down. Okay. In addition, these 4 subjects had a an overnight fast. Yes. Okay. So I have to check back if I did this right. So basically, yeah, overnight fast looks good. Okay, so we would have the tab, the group, and this we gave it a name. We call this these are all subjects. You could also do subgroups if you have multiple subgroups. But in our case, we only have like one group of 4 subjects, and these everything was measured, and this is everything which was measured. And then we basically need to get the data out of here. And so what we have to write down, like I would fill out first all the field, and in the end, what we want to have here is we want in the end some time values here, and we want some mean values here for the concentration. And probably like this looks a lot like I'm not sure. This could be SD or SE at this point. Okay, this is already a problem. I'm not sure if they reported if this was standard deviation or standard error, but we have to figure that out or make a educated guess. Okay, so this data, this was for the study Quinn 2017. This was measured in a group, in our group, like this all group, for 4 subjects. The intervention was at least 10, which we defined, and now something was measured. So we have to define, okay, what is like basically what is on the y-axis? And on the y-axis, what is measured is the concentration of a given substance. Our substance is here the lisinopril. So we know this is lisinopril because this was just an assay for lisinopril, and this here, it's also written in the thing. The tissue, we know this was measured in human plasma. The method, we also know this was like this liquid chromatography mass, tandem mass spectrometry. I just will, so it's LC MS. We just have to double check how this is called in the LCMS. There should be something in here, like we have like here, see, a method LCMS, so we can use it. So we'll write down the method. Okay, LCMS. We give the curve a label. In this case, we just call it lisinopril. I explain the labels later, and then we need basically we need some time data. So this part we have to fill out by getting the data points out of the curve. We know the time unit. This is in hours. You see this basically on the x-axis. This is data reported in hours, and then we have mean data which are reported. This is this here, and we then have also some mean plus minus, and this is probably an I would say it's difficult to say, but I would expect this is probably an SD. And we have a unit of this reported things, and the units are nanogram per milliliter. So this is the data which we have here. Okay, and this is basically what we have here. And then we want to we want to fill this out and get out this 10 or 15 data points which we have here. Okay. For that, we need a, okay, I'm just saving this here. So we were already pretty far. We have most of the information. We have the groups, interventions, and now we need just the actual data out of here. We would do this with a tool which is called plot digitizer. Let's see if I have this here. Plot digitizer. Oh. Okay, and this is just tools like this, and there we open now our screenshot which we generated. This is our kin 2007, and then we try to digitize the data. I zoom in and that's why here like the quality of the picture is really important. You should zoom in until you have this as large as possible. And now to get the data points out, we have to basically calibrate, okay, what is where's the x-axis and where's the y-axis, and then we can click on the data points and get the data points out. For that, we do the calibrations, and then we say this is our x value, it's a 0. Always be careful with the logarithmic axis. You have to really take care of, okay, is this log or not? In our case, it's not a log. We click on the maximum. So here, and this is also this is as good as possible. So this is a 40 here in hours, and then we calibrate the y-axis. So this is 0 down here. This is not logarithmic, and here we have a 45 up here. Okay, and this is it. And now we can give here, this is our time, and the y-axis is our concentration or Lisinobril. And then, okay, and then now we have this reference scheme like in which we can click. And so now we start digitizing. Okay, this is okay, this is okay. And then I'm just clicking on the points. Okay, here we basically know this should be a 0. And then we just click as good as possible on the data points. Okay. So in the end, there are some like AI-based tools to do that, but oh man, most of them, they work like for the really nice figures and so on, but even like for stuff like that, which is pretty obvious what's going on here, they often fail. So often this is faster than doing these tools. So then we click on done, and then we have here our values. We just copy that, going back to our spreadsheet. And okay, now we want the data to have it in here. I just copy it in here for now. Okay, this looks good. So, and then, okay, we know like the first thing which we digitized here, this was our time. So we can put this here. In addition, we know that there was the times reported. So like we basically know like that we didn't click perfectly because the times are basically, they are given here, like 1, 2, 3, 4, 5, 6, 8, and so on. But this gives you a good feeling of how bad are you in the digitization. And it's normally also like you're around like a, I don't know, like 1 to 3% you should be wrong in the clicking, but not much more. And this is doable. But in the end, okay, for the time we just can fix that. We just know that, okay, this is a 1, this is a 2, this is a 3, this is a 4, 5, 6, 8, 10, 12, 15, 24, and 36. So we know, okay, this is pretty good. These are the real times. We also know, okay, we don't need this here. And we know this is the mean data which we digitized. Okay, this is these values here. Now we want the errors. And for the errors, okay, we do just a second round of digitization, just closing this here. Okay, and so we click again on digitize. Okay, okay, okay. And then we just select the error bars, like so basically the first one, we don't have any errors. Okay, so I just click here in the middle, and for the other ones, okay, we just try to hit the whiskers here as good as possible. And this gives us this gives us basically the mean plus the error, or mean minus the error if you click below. And then we can calculate from this curve in combination with the mean, we can calculate, okay, what are our actual errors? Okay, and then of course we should have the same amount of points like before. Okay, so done. In this case, okay, the times, okay, sometimes I'm taking them just to be sure that the times are matching. But in the end, this, okay, I just copy that here. Okay, and then we just checked, okay, we have the same amount of data points, the times are matching, this is good, so we can get rid of the times. And so we just put this here. And then we can calculate the SD and so on. So here I would, in the comments, we write things which are strange. So in our case, okay, unclear if SD or SE. I would quickly check back in the paper, okay, if I can find some information about that. So, but you can already see this is it's not a really good paper because the focus was on the quantification of the method. But this is they don't even report if this is SD or SE. And it's difficult to say because it's 4 subjects and you have a large variability in 4 subjects. And they really don't say anything here. Sometimes you get a feeling of what they're doing in general in the paper. So like you can see like they're reporting a lot of SDs. And if they never mention any SE anywhere, then it's pretty likely it's an SD. But on the other hand, what people are often doing in such curves that they plot the SEs because SEs are always smaller than SD, and then it looks like your curve looks just better. So it's like often you find SEs in pharmacokinetic data. So so it's pretty unclear, but I would go with SD for here. But just write a comment, okay, that I was unclear, and then we can calculate the SD just as absolute difference between our column n, the mean, and okay, sorry, I have to do this. The mean and the mean plus minus the SD, which is our O column. Okay, and just quickly checking if this makes sense. So like, okay, this should be a difference around 0.04. Oh, okay, and then I just copy this formula and put it down. And this makes sense. Okay, this is okay here. You can see you have pretty big errors here, like basically like you calculate coefficient of variation. So like your standard deviation is 4 times as big as your actual measurement value. So like there's a crazy variability down here. Yeah. And then we can calculate the SE from the SD by just taking the using the square root of the subjects. So in our case, we have four subjects. The SE is always smaller, so we would have like the what is this? The P, not the P column. Is it the P? Yeah, I think the P column, and divided via the square root of our subjects. This was our count column, which is the D column. D3, D3. Okay, and then we have here basically the standard arrow, which is a bit smaller. Okay, and then okay, I just remove some of this numbers here. Okay, well, this looks pretty good. And then we have this data in here. Okay, we can remove the yellow parts here. The values you only would use if you have like individual data. In our case, we had group data, so we use the mean, and if we have errors, the SDs and the SEs. We filled out the data, the intervention we have. Okay, so overall this this looks pretty good. And we also didn't have any, like if you would have individual data, we would encode which individual was it measured in. Here we had this group data, and so yeah, this is basically the table here. Okay. So this was its part. Next part is now that we have to create this study JSON. Okay, we have here already one, and we have to adapt it a bit to our study. So we need certain information in here. So the first part is okay. You need basically up here, you just put again your Kin 2000 the study ID. And for now, you also put this as name and study ID. The next thing is that you have to figure out the PubMed ID for your paper. So I can just look this up from here. But you can also just search with the paper, search the paper on PubMed and get the PubMed ID. So if you know the title, in our case, the title was something here, this Kin 2017 and rapid quantification of lisinopril. You can also just go to PubMed and search for the ID. I see, no pre rapid quantification. And then you see this is the paper, and here's the same ID. This is the 1722 something. And this should be the same as we have in the study ID. Yeah. Then we have to write down who created that. This is your GitHub handle. And then we have to say, okay, who were the curators which are involved? In our case, you have to write yourself. You have to write the XResearch here. And so yeah, in this case, only I worked on that. And then you give a number for like, okay, how far you think you are along, something between 0 and 5. So normally like, okay, if you're pretty sure you're finished, this should be close to a 4 or 5. Yeah. And then you have different sections for different informations. So we basically have like here mapping for the groups. You have a sections for the interventions, and you have a sections for the for this outputs. Okay, and there, what happens here in this file, this is basically defining, okay, if we have our Excel file, how do we map the data to the database? So most of the time you don't have to change too much here. The things which you would fill out is like the descriptions. So here you would normally just copy parts of the, or some text parts of the paper, which correspond to the information in the thing. Like for in our case, like for the group section, we would normally just copy the this information here for Chinese healthy male volunteers participated. Yeah, unfortunately we can't. I don't think we can. No, see, we can't do that. So so I would just manually yeah, in this case it's unfortunate, but we have to just write this manually here. And this is just to have like the information from which I think what is the raw text from which we created our information for the groups. Okay, male volunteers. After fasting overnight, they got 10 milligrams BC, no pre tablet. And that's basically all the information we have. And here, here we map now these columns of our table. So basically these columns here, we map it on the database. So you basically you don't have to change anything here. The things which you would change is you write the descriptions here. We don't have any individuals, so you don't have to write anything here. Like for the interventions, okay, we also don't have much information. We just know the 10 milligrams lisino tablet. We don't know anything else, so we can just leave these mappings here. And down here, we would now say, okay, what is the data which we have in our tables? In our case, we only have one table, and this is the table figure 4, which we just created. We say, okay, the source of the information is the table 4. The figure which belongs to that is also the figure 4. This is a time course, and the rest of the things is, okay, it's just mapping the columns which we have already on the information. So the main thing you have to update here is like table information. And don't worry, this looks all complicated, but like in the course, like, okay, man, if you're stuck, I can just help you with that. And so I think the most important thing is like to getting the things in the spreadsheet. So, but this would be this this mapping file, and then we have everything to try to upload the study to the database, and for that we would just call this upload study script, and would say, okay, which study do we want to upload? So in our case, we want to have this data lisinopril kin 2007. We say upload the study. This is the command, and this just tries to upload it. In our case, we didn't initialize the environment variables. This is just this is basically setting, okay, to which database should this be uploaded and what are your credentials and so on. And this is basically a dummy database just for this XResearch. And you would use like this credentials in the end here to upload things. So we did that, and then we should be able to upload that. And then it takes the study and tries to upload the study. And then normally it gives you some errors. And in our case, it gives us the error, okay, this object lisinopril doesn't exist. And this most likely makes sense because we probably don't have anything about lisinopril in the database yet. And so if we search for that, we also see we don't have anything about lisinopril in the database. Okay, so to make this upload, I would just create this information in the database. This should take a few minutes. So we would just add some new information to the database, and we would add the information about lisinopril, and for that we would just look the information up first. So one thing I'm using a lot for that is the ontology lookup service, and there we get some information for that. So this is basically this KB information here, and then there's also PubChem, which is a good resource for chemicals and so on. I get also good information, okay, on what this is mapped to. Okay, man, why is this so dark? So dark, okay. And then we see this is basically this information, and we have to get this in the database somehow. Okay, let's do that. Okay, and so this information about substance is stored in this substance table. And I would just write this next to ramipril. So we will add additional substances which we need in the context of the lisinopril data and mapping. And then we just encode, okay, what is the information about the substance? And then just fill this out. In our case, we will add a new object in the database, which is called lisinopril, and add some now some information for that from this searches which we just did. So the one thing is that we know this is the PubChem compound. So this is this thing here which I'm updating. Okay. We had the KB information. This is this here. So I'm updating the KB information. This INHI key, it's actually a string hash for the 3D structure of the molecule. You get that also from here from the from PubChem. And this string is it's really it describes the 3D structure. And then I would look if I find the this NKit information, which is actually a clinical database, which normally has pretty good descriptions of the substances and is widely used in the field. And this is normally a pretty good description of what it is. And so we would just add that and check if this makes somehow sense. So lisinopril is an orally bioavailable, long-acting ACE inhibitor with antihypertensive activity. Specifically, competitively inhibits in ICE, decrease in the production of the angiotensin 2. Okay, this we already figured out. And diminishes vasopressor activity. Okay, in addition, the angiotensin 2 stimulate aldosterone secretion. Okay, this is also decreased. We saw that also in our data already. And sodium and water retention, okay, is changed. We don't have much data, or I didn't see data about that yet. Okay, but that's basically the information we need here. I would quickly look up the synonyms. These are often helping also in the literature research. So if you look up here, there are sometimes compound properties. You can see there are a ton of names to find it. I think the really important one is really the MCAF521, because this was basically how the substance was called before it came on the market. So a lot of these here is, okay, if you buy it in the pharmacy, but clinical research is not using these names. They're using lisinopril, or basically before it was named, it was like the MK521. So this is basically one of the really important synonyms, MK521. So I will just add this here. Okay. Okay, and okay, and do the same with a minus. Okay, and then we define basically what means if we say lisinopril in our table. It means, okay, we're talking about this substance here with this structure and so on. Okay, so this is this, and then I just have to okay, I basically have to update the database with that. I have here the research. Okay, I have to update the right database. We're just checking quickly if this starts running. And this takes a few minutes because it has to re-index the database and do a lot of things, but this looks pretty good. And so in the background, it now creates like a substance lisinopril for us. Okay. So now just to move on, I will just replace here the lisinopril with ramipril. And it's just that we get it uploaded in the database for now. But I'm marking things yellow if I'm unsure or if things are just wrong. And this helps me. Okay, so I'm not forgetting this is wrong here. But this is just done so we can proceed with the upload until the new information is in the database. So going back to that here, and we saw, okay, we tried the upload. A lot of things worked already, but it complained, okay, I don't know about lisinopril. So I just changed the information here and mapped it to something which exists. Okay, and then we see, okay, we have the same issue, of course, in the other table, because here, of course, lisinopril was also measured, and okay, it can't find the lisinopril in the database, so we just update that and try the re-upload. And this is basically what you try and like basically bring the data in the format that you can upload in the database, and if it's in there, like and all this, like basically here, this looks pretty good. If you see that here and it starts indexing, then all the data it worked, and we have everything in the database. Okay, sorry, this is just the REST endpoint, and then you can access the data. So we created that, and now we have this new study, basically the XResearch, and we created that. And we have one group in there. This is like this Homo sapiens, healthy, 4 males, Chinese, they were overnight fasted. And we have certain outputs here, and especially this time courses. And so this looks pretty good, and it looks like the curve we had. This is also like all the right information here. And we have like some additional outputs here. There's a lot of concentration, but you can see also there are like things like volume of distributions here, area under the curves. And these are just parameters which are calculated in the database. So the database figured out, oh man, this is a pharmacokinetic time course. And it's after a single dose. So we can calculate certain pharmacokinetic parameters. And so it calculated like some of these things. And so we have like an area under the curve until infinity and so on. Okay, so that's the basic idea of the that's basically the basic idea here of the data upload. Okay, let's quickly check if the okay, that's successfully created, but this here, this really this takes forever. This upload, but okay. Okay, so far so good. So this looks good. I'm just fixing here this lisinopril. Yeah, fixing this back to the right values. And if the new information is in the database, this should all upload. We just have to re-upload it to update the information. Okay. And the intervention was also wrong. Okay. And so at this point, yeah, we have to definitely save the data because we did a lot. So like here in this case, I would just add all the git so we created a study and have this data now to do a simulation with that. Okay, there are some additional things which we normally do in this process, and this is just to track the information, and this is basically we're tracking information here. So in this case, okay, this is already created. So this is basically this is good. We had like and just checking that all the fields are right. So okay, the first thing, okay, I have to check if we added an issue on so here, this is the first point. I have to check if I created an issue on GitHub, and I didn't. And this is what normally the first thing we should do, that I also can track what is the progress and what are things happening with this studies. So normally the first thing you do is that you open a study, a GitHub issue for your study, and you just call it create and then the lisinopril and your study ID, 2007, and say who is assigned. So you assign yourself to that, and then you give certain labels. In this case, it's data. And okay, and we have to add a new label, for lisinopril. I would say, okay, this is an issue related to data and lisinopril, and this is here. And then, okay, normally I'm also listing, okay, what has to be created. In our case, this is figure 4. And we already, okay, we already did that. And so normally you would basically do this at the beginning and just not fill this out. In the end, you would, if you have questions or if there are issues with the study, and you normally communicate via this issue, and then it's pretty clear, okay, this is related to this study and so on. And if you're finished, you normally just close this issue. So this is here, and this goes then in the creation in a second step. And I have to check that the information is correct. And so as soon as this check tag is here, okay, you don't have anything to do with the study anymore. It's more like okay, all the data is there, and I have to do some additional validation checks and review the data and so on and check that everything is okay. And this is normally how this would work through the process, that you open at the beginning an issue for that, and then it's easy for me to track, okay, what is going on with the study and so on. And so, oh, sorry. How does this work? What? Start hyperlink. Oh, I could add some hyperlinks to that. How does this work? Yeah, I was confused. Ah, okay, here. Oh, that is fine. Okay. And then, okay, that's the first thing, okay, that we basically have an issue, which is tracking that. I would give this first check here because it's in the repository. The second thing, I have to check that all the information from the study is in the documentation. And that means as, okay, did we add this here to this documentation and where it is relevant? And we only have like one curve in here, which is a pharmacokinetic curve. Okay, and this is already added here to our overview document. So we know like all the information all the data which we curated, it's already here in this document. And so we can check also this here. Okay, this also uploads. Okay, that's pretty good. We didn't do a simulation yet with the data, and we didn't use it in parameter fitting. So no checks here. And then we have to fill out the other data. So we know this is from healthy subjects, and it's there's neither renal impairment nor cardiac impairment. And then and we have to say what is measured. Okay, we have only lisinopril. Okay, there's no data in urine or bile. And then we have to check, okay, was anything else reported here? No, nothing of the pharmacodynamics. So we fill this out. And okay, in the end, I would also put the title of the study here at the end, so that we have the information in the table. Okay. Okay. And so this is basically what is happening normally, that we can track what is going on, and then we know now, okay, this is like already, we have like some pharmacokinetic data, which we, it's creating, uploading, looks pretty good, and we can use it for model parameterization and fitting. There are no issues with that. Okay, and this is pretty good. Okay, so let's check it back to the data. Okay, this looks good. The things is uploaded. So, and now if we look back to the database and look here in the fields, we should be able to find the lisinopril. And you see here, so it's we have all this information. Okay, a lot of synonyms which were resolved automatically. Cross references to other databases. So we know if we talk about lisinopril, this is what we're talking about. And we can use it now in our spreadsheets. So for the thing I changed back, it should now upload. So if I look back here and do the re-upload. Oh, this is the wrong thing, sorry. I have to upload the right study, lisinopril and kin. This would now upload because we have the information. Okay, looks good. And I can I will just quickly check that this works. And now we see on the interventions that we have, okay, the dosing was lisinopril here. Okay, looks good. The right thing was given, and we see, okay, this lisinopril here. Okay, this is all the information for the database and what we wanted. Okay, I would say this is a part here from the data curation. Well, and this was like basically the speed run through the whole thing. this is what you do, and then you go next steps. But this is a bit what you're doing through the 1 week course. So part of this is not the whole week, but part of that is definitely figuring that out. And then the next step is then that you that we do some simulations. And this is what you see here in the experiments. Like for instance, for this Allegrini, you would then use the data which we then created, and then use run some simulations here. So here, just okay. Wait, this was wrong. Yeah, but this would be the next step, that you then say, okay, now we want to use our computational model for Lisinopril and simulate the data from Quint 2007 and compare, okay, how did the simulation curve look in comparison to the actual data. Okay, for that to do, probably I'm not sure. Like at this point, we probably have to assign some of the studies. So it makes sense that people somehow start with that, and we have to put the names in the here in the sheets. Like I said, this kin thing, like this was pretty easy. So I probably also would do the second one. It's okay. But this is also not so high priority. You could say like there's pharmacokinetics data in there, and it's really nice for model fitting, but it's not so important for the. It's not the. There are other studies which are more important, but they are also more complicated than what I showed here. Especially if like additional pharmacokinetics info, pharmacokinetic parameters and so on. And so, not sure. We should just put some names in here, and I have to figure out, okay, who is in which course. So definitely definitely the names I have in the first course, they should do the first studies. So okay. I have to see how many people are coming. Oh, okay, but this is second one. Okay, and the second names I would put probably here. Okay, if there are questions about that, just ask me. But I'm look my here. Yeah. If anybody is missing here, I'm not sure if I Amanda, I think I missed.
Yep, I'll be in the second group.
The second group. Okay, but you can that's okay. You can do one of the first ones. Okay, so I would say this is no worries. Okay, this is okay. This is just I put this arbitrary in here. And in the end, you will all do like around two studies. So it's normally it's pretty do. You saw like okay, this was a very easy study, and I know what to do. So I need 45 minutes to do that. Okay, and you probably need like probably a day, 1.5 days to do that. Like for the okay, but of course you can read the paper. Like you can read the paper now, and then okay, most of the time it's say it's not. it's not too crazy, but like in during the course in like 1.5, 2 days, you should have most of the stuff done. And then you do the simulation and this is most of the contribution. And then the model, like during the course, we develop the model together. And so it's more like, okay, we have to get all this data together with the model and do the model simulations for all the different cases and figure out what is special about every study and so on and so on. But this is basically what will happen during the courses. Okay, so we probably like not too many people doing the course next week, which is okay. So yeah, can just be so that's probably pretty focused, and we can just focus on the pharmacokinetics, and we'll okay. And if the first group is doing another, like I think we have 3 or 4 people is doing another 3 or 4 of these high priorities, then we have already most of the things which we need from the pharmacokinetic part. This looks pretty good. Okay, also like these are all the people which I have on the list for the course. So if somebody is still missing on here, please let me know. Like I mentioned at the beginning, like if you really have to participate in one of the courses, because there is like the actual work, because most of the work I did until now, I'm prepared and so on and so on. But now, like, okay, you have to read the papers, you have to get the data out, you have to simulate the things, bring it together with the models. This is all the actual work, and this is happening in the course. And so, like, if you're not participating in the course, you're also not getting the you're not successfully participating in that. That's just how it is. But and like I said, like we still we also like really do the 2 courses. But if you miss like 2 or 3 days, like there's still some opportunities to do it on a different days, because some of the work it's really okay. I don't have to sit next to you all the time, so still can work. Okay. Okay, are there questions until here? Okay, if not, then okay, we still have a bit of time. What I would do is now, okay, let's see how far we can get in running a simulation of this model, just to get a feeling of what is going on. So let's do a quick speed run of like, okay, creating one of the models. Okay, and for that, what I would do is just adapting the Rami-Priel model which we have already. So what we did so far for the actual model part is that we built this kidney model, and we didn't put too much stuff in the kidneys. We basically said, okay, in the kidneys, lisinopril can be taken up and it can be excreted in the kidneys. And this looks pretty good. And this is also like from the data, it looks okay. Lisinopril is not too exciting from the pharmacokinetic part, but mainly what's happening, we don't have any metabolism, so most of it is just lisinopril. But we have like some low bioavailability because a large part is going in the feces, and most of the things are just excreted in the urine. And we saw this also in this renal excretion. Renal excretion data, that okay, we basically see like a lot of lisinopril appearing in the plasma, and we see this also in okay, things like here. Okay, we get a lot of amount in the urine. And you can see here like around 2 milligrams, 3 milligrams. This is probably a 10 milligram dose. So around 20-30% is appearing in the urine, probably a bit more after like 48 hours. But around 60% is likely going in the feces. But these are I think we had like 1 or 2 studies where we had like really a table with the urinary recoveries and so on, fraction of dose in urine. Here we saw that, okay, it's really small, but this is 30%, 25%. So it's like a third. Here we have excretion in urine and feces, and you can see for the lisinopril, okay, around a third, 29, and so on we have in urine, around 70 we have in the feces. A large part is really not absorbed, and the rest is really okay. It's excreted by the kidneys. So this is a pretty from the pharmacokinetic part, this will be a pretty simple model, and on the kidney model, we basically had this very simple model of okay, we just pull it out of the system. So this was basically what we built here. We just say, okay, lisinopril, which is in, if it reaches the kidneys, it can be excreted. So this is basically the one part we have. We would build now a second model, which is the intestine, and here we take care of this partial absorption of the lisinopril. So this is our would be our first intestinal model, which we call lisinopril. In the model in the kidney, we know like okay, we have like different compartments. Here we have an external compartment. We have the gut. We have the lumen of the gut, which is the inner part. We have the feces. So this is everything which is not absorbed in the intestine. It will reach the feces. We have this entero, which is the entero sites. And then this is not so important. And we have a stomach. And then we can, transport the lisinopril, which we take as a tablet, through the system. So in our case, we have the, we call this LIS, and this LIS can be either in the stomach. It can be in the lumen of the intestine. This is the inner part of the intestine. So after the stomach, it's reaching the intestine. So this is here. It can be in the plasma, which is associated with the intestine. So this is after the intestine absorbed it over the enterocytes and the intestinal barrier. It goes into the venous blood, which is in the intestine, and this is basically this here, Lis extern. This is a plasma which is associated with the intestine. This is where the substances could be, and then it can be in the feces. Yeah, that's basically it. In addition, now we have a fraction absorbed, and this gives us the amount of which is absorbed. And we know like around 70% is in the reaching the intestine. So this is the fraction which is actually absorbed, so around 30%, and this is the 30% which we find also in the urine in the end. Okay, and this is just an approximate value which we saw like from the data, like just having a look at it. In the end, this will be determined with parameter fitting and so on, and also we use the data more specifically. This is just in the beginning, we need just like the main processes which are in, and the right house numbers, like this is like around 30% are absorbed. And so this is basically this, and so the 1 minus this fraction absorbed, so 70% is excreted in the feces. Okay, and then we have a rate of absorption for lisinopril. So this just tells us how fast can lisinopril be absorbed by the stomach, and this is just a first order absorption process. We in the one course, like we had like this different absorption models, like with we're doing this linear chains and more complicated absorption. Here we just have like a very simple first order absorption, which means, okay, we have like this absorption rate, these ups K, times the amount of lisinopril we have in the lumen of the intestine. And the V gut, it's just doing a scaling with the volume. So more like that. Like if you're a big person and have a lot of intestine, then you have also a lot more absorption. So this is basically the scaling which is happening here. Okay, then we have certain reactions. So the one reaction is the actual absorption of lisinopril. I probably will just place all of that here. Yeah, that's not nice. That's real. That's lisinopril. That's we didn't like. Okay, we can't replace that. Okay, let's go through it. So that we have one parameter, which is the actual dose of lisinopril, which we give. We have a dissolution parameter, which tells us how fast is the tablet dissolving in the stomach. We have a molecular weight of lisinopril, which is available online. Sorry, I will need 5 more minutes when I'm finished here. Quickly, I just want to build the intestine model and then, man, where's the molecular weight? Here, 405.5 grams per mole. And this is basically to convert between grams and moles. And then we have the solutions. Okay. And then we have, okay, I have to replace these things here. These are all, oh man. Yeah, not that. Oh man. Okay, here we have to replace all the species identifiers. Okay, and then in a second it will be more clear if you see the graphical overview of what this is. And this is okay, transporting the list and the feces. And okay, then we have this here. And then we can just check quickly if we can create the model. Probably still some, exactly, there are some errors in here. The annotations, was probably did a was we most likely don't have the lisinopril in here yet. Here. Okay, that looks good. And that build a first version of that. Okay, and that that's basically just showing you, okay, what is happening. So we have lisinopril in the stomach, and then we have this dissolution, which is just the tablet is like dissolving, and then it appears in the intestine, in the intestine. And then two things can happen, like either this is absorbed, and this is happening with this fraction absorbed, so like around 30% can be absorbed, and the other 70% are like excreted and appearing in the feces. And so this is basically what is happening. And so in the end, this intestinal model gives us like some parameters for the rate of dissolution and the rate of absorption, and gives us some flexibility in saying how much of the dose is really appearing in the system. And so this is mainly like the how I say the submodel which brings the lisinopril in the system after an oral tablet. The kidney model is the one, okay, which is removing it from the bloodstream. And so in the next step, we have to build a whole body model for the circulation of the lisinopril and connect all these parts together, between this absorption part and the removal part. And if we have these two things, then we can, of course, simulate similar like in the like I showed with this simple absorption models. We can simulate, okay, how is this appearing and disappearing, and compare this model simulations with this example data we had or created today, like this. That we can compare the simulations with this figure here. Okay, so far so good. So what we did today, in summary, is like, okay, we created one study. This showed, okay, how to do that. You all have like one of the study assigned. I will send the list around so that everybody's aware, like which paper to read. If you're in the course next week, like try to read the paper before the course, and then have a look, like, okay, at this Quinn Excel sheet and how the files are looking, so that then you can, it's easier to get started on Monday. Yeah, for the others, please read the papers, and yeah, I think that's from my part. I will commit all the changes, and you find all the PDFs already in the repositories. Okay, so if you have any questions, yeah, just let me know. Yeah, perfect. Okay, there are no questions. Then see you all around. I upload the recording. Yeah, hopefully today. Okay, see you all. Bye.
Bye. Thank you so much.
Bye-bye.
Bye. See you.